Welcome to BKW Physics. I'm Mr. McConley, and we're going to go over a problem here. The problem is, a rock is thrown vertically upward with a velocity of 21 meters per second from the edge of a bridge that's 42 meters above a river. How long does the rock stay in the air? So we have a diagram here which spells out some of the things that are in the problem. But the first thing we got to know is that the initial velocity when it leaves is 21 meters per second. We also have to know that when it gets to the top, when it flies up to here, what's its velocity? Right at the top. Yes. Final velocity right up here is 0. And to begin with, that's kind of all we need. Okay? Because during this whole time, what's the acceleration of gravity? I hear a lot of people saying it's 9.81 meters per second squared. That is true. So if we want to find how far the rock went up, I think we got enough information. Let's start here. So we'll take and we'll say, okay, Vf squared equals Vi squared plus 2gV. We're going to rearrange it for d. We're going to say Vf squared minus Vi squared divided by 2g equals d. Now we're going to plug in. Our final velocity is 0. Our initial velocity is 21. Got to remember to square it though. And that's all over 2 times negative 9.81 meters per second squared. To speed things up a little, I've done the math in advance. And it turns out that that distance is 20.4 meters up. So now we know that this thing rose up, this rock went up 20.4 meters. Well, how much time did that take? So the best way to approach this is say, okay, acceleration is the change in velocity over time. Remember, change in velocity is final minus initial velocity. When we rearrange it for time, we're going to get time is the change in velocity, final minus initial, over acceleration. What's our final velocity again, everybody? When it gets to the top?
0.
What's our initial velocity when it leaves your hand? 21 over an acceleration of 9.81 meters per second squared. Well, anyway, math shows that that is just over 2 seconds, 2.04 seconds. That's how much time it takes to get up here. Good. Well, I guess we got to figure out how much time it takes to get back down. So let's go to this equation. Distance equals VIT plus 1/2 GT squared. Now at first, it doesn't seem like this equation is going to work because we're trying to find time, and time appears in 2 places. But what's the initial velocity? Now, this is like a new problem right here. We're going to start here and we're going to go down. So what do you call this up here? This is now the initial velocity, and the final velocity is all the way down here. Okay? So the initial velocity is 0, and if this is 0, what does it do to this time? Cancels, it's gone. Now the problem is doable. So we're going to ignore that phone. We're going to go times by 2, so 2 times d over gravity. I'm going to take the radical, and that's going to equal the time. So I just did a rearrange, and you can do it in more steps, but I'm trying to abbreviate it so we can get it all on the video here. So we're going to take 2 times the distance. But what is the distance? The distance is the 20.4 plus the 42, because it fell all the way from here down to here. So what does that add up to?
62.4.
62.4. Thanks for staying with me. And then we're going to divide by gravity. And through the magic of a handy-dandy calculator, we're going to get that the time that it fell for is 3.57 seconds. I don't know if you can see that. It might be too low on the screen, but 3.57 seconds. So now to finish the problem up, it fell for 3.57 seconds, and it went up for 2.04 seconds. So So when you add those two times together, how long was the thing in the air for? If you add those, it was in the air for a total of 5.6 seconds. And that is the answer to your problem. So for today,